Tonight's special guest speaker, Dr. Justin Perrault, is the Vice President of Research at Loggerhead Marinelife Center. Growing up in Tennessee, Dr. Perrault's first encounter with sea turtles came in 1990 during a visit to the Children's Museum of Juno Beach, the precursor to Loggerhead Marinelife Center. That childhood visit unknowingly shaped Dr. Perrault's career as a scientist. Dr. Perrault received a bachelor's degree from the University of North Carolina, Wilmington, and a PhD from Florida Atlantic University. He's also on the board of directors of the International Sea Turtle Society. After graduate school, Dr. Perrault held a postdoctoral fellowship at Mote Marine Lab and a faculty position at the University of South Florida. In 2017, he circled back to Loggerhead Marinelife Center to lead its research department. Dr. Perrault and his team conduct sea turtle research on one of the most densely nested sea turtle beaches in the United States. Tonight, he's going to show us how the scientists at Loggerhead Marinelife Center are working to protect Earth's last living dinosaurs. I'm really excited to welcome to the stage Dr. Justin Perrault.
Thank you, guys. I'm so excited to be here in front of a huge audience. It's a little bit of a risk for them to keep the fire alarm right on the entrance on the way up. I may want to pull that in case I get a little nervous. But today, as Zach said, thank you guys for hosting me tonight, and again, as for all of you for coming. I'm going to tell you guys a lot about what we do tonight at Loggerhead Marinelife Center in our research department, which has a really long history with the leatherback sea turtle here, about a 30-year history of monitoring these animals. However, many of you in here have probably been to the center. This is what you think of when you think of Loggerhead Marinelife Center. First and foremost, we are a sea turtle rehabilitation facility, but we have a number of other facets of things that we do there. So when you're there, you see a lot of animals that are sick, that are getting better right now. We've got a lot of Kemp's Ridleys that cold stunned from New England and came down. This is Medusa, and she actually lives up to her name. She is a snake. She likes to bite all of her friends. So she has to be in a tank by herself. But we do a lot of research projects on the rehabilitation animals. We take in hatchlings and do a lot of educational programming with children. As I said, however, we also have the research department, and this is mostly what I'm going to be talking about tonight. This turtle here that looks, I do give them little head scratches when they're on the beach after they finish laying their eggs, and we like to smooth the sand off of the heads and look for any injuries and assess body condition. And this photo was snapped by some donors of ours this summer, and it's one of my favorite photos I've ever had with these animals. This is Dot is her name. They all get names just so it helps us keep them apart, tell them apart. So sea turtle nesting season is almost upon us. I have March 1st through October 31st in quotes because that's a human-based calendar, and as we know, wildlife does not abide by our Julian cycle. So last year, the first nest in Florida was laid actually on February 4th in Blowing Rocks, right near here. By a leatherback sea turtle. It was the earliest nest on record, and we're starting to see these animals that are coming earlier and earlier year after year, likely due to climate change, which is triggering them to make their migrations further south. So these date ranges are in quotes. We actually just had a nest hatch last week by a green turtle. So really in the southeastern portion of the state of Florida, nesting season for sea turtles is truly year-round. For LMC, we monitor about a 9 to 10 mile of beach in the northeastern stretch of Palm Beach County. So our northernmost boundary is at the Martin County line, and the southernmost boundary is at the MacArthur Beach State Park. And this area is just incredibly densely nested. It's one of the most prolific nesting areas in the world, and I'll show you guys some of that a little bit later. There are 7 species of sea turtles that exist in the world. 5 of them are found in Florida's waters. So we typically do not have the olive ridley here. It's usually a South Atlantic species, although we do have some evidence of stranding by these animals in the state of Florida. And the flatback as well, in the middle, is only found in Australia. So we have never seen one of those in the state of Florida. The other 5 that we have here are either found in our waters or on our nesting beaches during the year. You've got the leatherback, which is the largest, the easiest to identify. They look like a A lot of people compare them to Volkswagen bugs. They look like, just a tractor trailer has run along the beach. They're remarkable animals, the largest turtle in the world and the second largest reptile. The second is the green turtle. They're, as you know, we may have heard in the news, the green turtle was just downlisted from endangered to a species of least concern globally. And due to a lot of conservation efforts that have happened worldwide. We also have the loggerhead. The loggerhead is kind of Florida's bread and butter. It's our most common sea turtle that we get nesting here. We typically get over 100,000 nests in the entire state of Florida from the loggerhead. The green turtle's catching up though. We also have the less common nesting species, but more common in our waters, are the Kemp's Ridley, which is the smallest species of sea turtle, and the hawksbill, both of which are critically endangered species. So when we are on the nesting beach, we're kind of like detectives. We have to see what went on. What did the turtle do? Did she lay eggs? Where did she lay those eggs? And what species was she? So the leatherback is easy, right? It's as wide, the crawl is as wide as I am, if not, or as tall as they are wide, as wide as I am tall, made by, again, a very large animal. Now the loggerhead is a lot smaller, and they're gonna do the freestyle. If any of you are swimmers, they crawl up the beach and they're doing the freestyle stroke like that. And they make these comma-like marks in the sand that are not parallel to one another. So these are how easy ways that we can tell them apart. Now the green turtle kind of looks like a ladder. They're gonna do the butterfly. So they're crawling up the beach in a butterfly position. They have a tail drag down the middle that you can kind of see there, and their flipper marks are parallel to one another. So based on these cues that are left in the sand, we can tell what species of sea turtle laid its eggs. Sometimes we get really lucky on a really high density nesting beach and we see all three species right next to each other. This does not happen often. It actually happened in 2025, which was a really busy season. We had a loggerhead here, a leatherback here, and a green turtle come up right next to each other in a single night. So that was pretty interesting. So I know, the hatchlings are cute. They're not fun when they're adults. So the hatchlings, what's really interesting, I just told you the green turtle as an adult does the butterfly. As a hatchling, it actually does the freestyle. So those change over time as the turtles grow and age and get heavier. So you can see this is a green turtle from Hawaii, but you see she's doing a very different stroke than her offspring that you can see there on the left. And that's likely a difference in distribution of body weight or something like that that just changes the biomechanics of the animal and how they crawl. So it's really interesting to see how these behavioral changes occur over these 30-year histories that these animals have. Forward. Okay. Pop quiz. Anybody guess what loggerhead, right? So you've got the classic comma shape. It's not always that easy. Sometimes the turtles like to trick us if they've got a missing limb or other kind of injury. Their crawl is a little bit different, and oftentimes a loggerhead can look like a green turtle, but then you use some other cues or clues in the sand that might tell you the difference. So 2025 was an incredibly busy nesting season in the state of Florida. We had in the statewide about 160,000 sea turtle nests from northeastern Florida all the way over to the Panhandle. On our stretch of beach that Loggerhead Marinelife Center monitors, about 9.5 miles, we had 21,000 nests, which translates to around one nest every 2 to 3 feet. This was the third highest nesting season that we'd ever seen, indicating that a lot of these conservation efforts that we have currently protecting these animals are working. So this is kind of the trend over time. You've got year here on the horizontal axis and number of nests on the y-axis, and this is just for our local beaches. You can see that over time we are seeing a gradual increase in the number of nests, which we are very excited about. And I used AI to predict what our nest numbers might look like in 2026, which is there in this gray bar. And it told us basically we're going to have another crazy season, which nobody's really that excited about. It's a lot of work, a lot of hours lost of sleeping, but it's really cool to see all of these animals that we have. And you may say, oh, AI, last year AI actually got within 7% of our entire the predictive nesting. So it actually did quite a good job. So, we're not sure if we want it to be right or not next year with how much work it is. And those are just the number of nests that we had by each species. So the leatherback is the most rare in the state of Florida. This was the first year the leatherback in the state of Florida actually broke over 2,000 nests. So again, doing quite well here. The loggerheads are at least stable, if not increasing, and the green turtles are the ones that are really driving these nesting trends. So our 2026 prediction, as I said, is about similar to what we had this year. And now I'll go through kind of each of these species individually. So the leatherback, over time, the trend in nesting hasn't been quite so obvious. We have a lot of ups and downs, which may just be basic biology of the species. A sea turtle does not return to lay its eggs every single year. It's incredibly energetically costly for that nesting female to lay her eggs, to make those migrations. And she does that entire process. She's here for months and she doesn't eat during that entire time. It's a strategy known as capital breeding. So what they're doing, they leave the nesting beach after laying a number of eggs and a number of nests that I'll talk about a little bit later. And then they go migrate to their foraging grounds. They gorge on whatever prey item that they like. They really develop those fat stores in their body. And then once that energy level gets high enough, they'll make that migration back down to Florida or wherever their nesting beach is every 2 to 3 years on average. So we often see these peaks and declines in nesting in sea turtles just because of their natural life history. So overall, what we're seeing is an increasing trend in leatherbacks on our local beaches that we monitor just south of here of about 5 leatherback nests per year. Again, that's pretty good. The leatherback was recently just uplisted from least concern to endangered globally. So I'll speak on that again also a little bit later, but in the state of Florida, they're actually doing quite well. Now the loggerhead, again, these are the ones that are just nesting everywhere. So over time, again, you can see the same trend here is upwards. This 2025 prediction is a top 3 year for the loggerhead. And over time, we're getting about 350 nests extra every single year. So all of these populations that we're seeing are growing, at least in the state of Florida. And the green turtle is kind of the weird one. They're my least favorite of all the turtles. They're when they're little, they're okay. When they're big, they're tricky. But they threw us for a loop. The green turtle in Florida was near extinction about 20 to 30 years ago due to overharvesting of the eggs for their meat, just general fisheries interactions, a lot of threats that these animals experienced. And you can see back in 2001, we documented on Loggerhead's beaches 63 green turtle nests. And you see over time, those have grown exponentially, where we had 8,400 this year. So a 2 orders of magnitude increase in nesting over a 20 to 25 year period. Now the greens used to be very predictable. They would do a low year and then a high year, and then a low year and then a high year. And they did that for about 10 years, and we were very happy about it because we could predict our season, we could tell how many staff we needed. And then all of a sudden they decided to change it up and have 3 mid-years, and then a giant year, and then a low year, and then a high year, and then and then next year we'll see. So it's been really tricky to kind of figure out how much staffing we need and how much resources we need every year just because of the green turtle. But again, very happy that their species are doing well. And again, overall, it's about an increase of about 250 nests per year on our beaches. So overall, we're seeing an increase of about 600 extra sea turtle nests over year on average. For those of you that have never been out at night to experience this in the state of Florida, especially on the southeast coast, it is remarkable. So here, this is just north of the Jupiter Inlet during peak season in June and July. Each one of these represents a sea turtle crawl. Most of these are loggerheads, but you see it is literally turtle after turtle after turtle after turtle. We see them back to back. We see them digging up nests. We see them flinging hatchlings in the air, crawling on top of each other. It's a very special place. And here, this is down in Lost Tree, just north of MacArthur Beach State Park. and each one of these points represents a sea turtle nest on our beach. So you see that during sea turtle nesting season, pretty much every piece of sand is touched by a sea turtle at some point during the year. And just again, making us a really, really incredible area, making our area really incredible for a lot of these research projects that we do. Now in 2025, our estimated egg production, we don't mark every nest because if we did, there would be no place for tourists, right? We need the tourists, we need the ecotourism. So we can't mark every nest. We only mark about every 5 to 10% of our total nests that are on the beach. So every stake you see in Juno Beach or Jupiter or Tequesta, there's about 20 nests around that have not been marked that are underneath the sand. That's why when we tell people to go to the sand, if you're using, or go to the beach, if you're using an umbrella or digging anything, pushing anything into the sand, you want to dig down a little bit and make sure there's not a clutch of sea turtle eggs underneath it. So on our beaches, on our 9.5 miles, the turtles produced over 2.3 million eggs and about 650,000 hatchlings. So that may seem like a lot of hatchlings. It is a lot of hatchlings when you think of their survival rate being likely less than 0.1% as a very small animal. The other problems that we're seeing, this is only about 30% of the total eggs that were laid on our beaches. So we see climate change causing an issue as nests get too warm. The embryos cannot survive. We often see tidal overwash or washout due to increasing tropical storm or tropical cyclone frequency. We get predators are okay, right? Nobody wants to see a little cute baby get eaten by a bird, but the birds have to eat too, and so do the coyotes and the raccoons. So we're okay with it, but most people aren't. And so that's our morning program in a nutshell. We're out there every day from when the first nest is laid until that last nest hatches. Last year that was November 16th, but the year before it was mid-December. So our years it all blends together, it all blurs. I can't believe it's here again. So the morning program is a lot of what people see most commonly. However, our night program is kind of the hidden gem of Loggerhead. We started the tagging program back in 2001, and we still have animals that are coming back during that time. I started at Loggerhead Marinelife Center in 2017 officially, but I did my PhD work there in 2007 and 2008. We still have turtles returning that I sampled 20 years ago to the beaches, and so it's like a full circle moment in your career that you kind of see these old friends that have millions of stories to tell. So we do have this nighttime tagging program that I mentioned that focuses primarily on the leatherback, but as our program has grown in number, we've started doing a lot more with the other two species, the loggerheads and the green turtles reluctantly. How many of you in here have ever seen a leatherback turtle before? Not very many, right? It's pretty rare, but they are truly incredible. So as I mentioned in the title of my talk or the description of my talk, they are often known as Earth's last living dinosaur. And they've been around 100 million years. They've long before humans, long before all the other sea turtle species. They evolved from Archelon, which is even bigger than the leatherback. And you'll hear why they are given that nickname. She does it again. So that's Costa. She's one of our OGs or original girls that we call her. She was one of the first ones that we ever tagged back in 2003. Still nesting. We've seen her about 16 times since that time, and she's one of the noisier ones. They don't all do this, but it is my favorite part about them. And what's really cool, one of my coworkers, Jen Riley, is deaf, and obviously she can't hear the sounds that they're making, but this last year, she had her hands on the animal when it was making the sound, and she felt the vibrations. And so she was able to experience it in a way. I was just happy that she was able to experience something that we all think is so special. So I went to the punchline on accident, but you'll see. So this is Miss Piggy. She was a neophyte, meaning the first time we ever saw her was in 2024. She'd never been tagged before or seen by any other researchers as far as we can tell. She made some funny noises. So she's done nesting. She's covering her eggs. And they don't care. The leatherback does not care about anything. Their size is their protection. Their only real predators are large sharks like tigers, whites, makos, maybe a killer whale every now and then, but that's about it. So on the nesting beach, we still give them their space and their privacy as they're laying their eggs and doing all of that. However, they're a little less finicky than the other two, which I'll show you a little bit later. And leatherbacks are really remarkable animals because they get to this size. So these animals, the largest one ever was clocked in at 2,000 pounds. That is a remarkably sized leatherback. That's not common. On a foraging ground, a leatherback, it likely weighs about 1,500 pounds maximum. Still a really large animal. They're competing with the saltwater crocodiles for size. And they get this big base just foraging or eating on a diet strictly of gelatinous zooplankton. So we call them gelatinivores. It's kind of a name that them and very few other animals really do a lot of. This is a pyrosome, which is a colony of just free-floating tuna, essentially filter-feeding organisms, but they eat a lot of jellyfish. So you've got lion's manes, cannonballs, moon jellies, and they're up to their body weight every day in jellyfish to regain that energy that they require to make those migrations to mate and nest throughout nesting season. So this is what it looks like. This was a group out in California that put a camera on the back of the leatherback. Okay. So there's a jellyfish, and boom. Big bite. They close their eyes so they don't get stung. That's the only part that's vulnerable. Their skin is covered in keratin, just like your fingernails. It's a really thick layer of keratin that does not cause them any harm, as far as we can tell. And they just swim along and eat these. A lot of times what they're going for are the tentacles, which are much more nutritious than the bell or the top. However, jellyfish is about 95 to 99% water, so you know why they have to eat so many. And trying to move forward here. Stuck. Hang on. There we go. So before okay. So the leatherback, again, anatomically, they're very unique from all the other sea turtle species. They're in their own family of organisms. There's no other species like them on Earth. And the way that they're able to trap these jellyfish in is through these papillae. So these are made of keratin as well. They're not really sharp. They're kind of bendy. And all sea turtles have these, but it's not quite as dramatic as you see in the leatherback. It sort of looks like something from Men in Black or some alien creature. Unfortunately, this was in South Africa. I went down there to do a little bit of research on their leatherbacks and teach them about health assessments of the leatherback turtle. Unfortunately, this one crawled up on the nesting beach and passed away for whatever reason. It may have been some kind of egg embolism or something in the body where she couldn't pass her eggs properly, but otherwise looked in great body condition. We took the opportunity to try to learn as much as we could. And so they have these papillae in the throat, and I'll play the video in a second. And what they're doing is they're swallowing those jellyfish, and they don't want that extra salt water because their food already has enough salt water in it. So those papillae are faced backwards in the throat. And what they do is the jellyfish comes in, and then it gets trapped in those papillae. They squeeze their mouth shut, and all of the water flies out of their nostrils, which sounds awful. And then the jellyfish prey is stuck in the throat. I'm going to turn, I don't know what we're saying in the video, so I'm going to turn the volume off. Yeah, they do have, the tongue is coated in these papillae as well. So unfortunate that the animal is no longer with us, but again, she's in great body condition, so most likely something with her reproductive tract. We also do at Loggerhead, my background is in animal health and toxicology. So I take a lot of blood samples from a lot of animals. I think I've taken more blood from leatherbacks probably than anybody on earth. I train people in this from all over the world. I've been doing it for almost 20 years now, and here's how you take blood from a leatherback. In case you're wondering, it's not something that most people get to see often. So unlike the other sea turtle species, you take blood from the jugular. In the leatherback, the jugular is about 6 inches deep, so you don't really want to do that. So what she does is she's very kind. When she's laying her eggs, she drops one rear flipper into the clutch. And then you're feeling for the knee and then moving inwards into the tibia and the fibula in your legs, same bones. And there's a really scientific term called the squishy spot. So once you find that, if you're queasy, I'm sorry, when you find that squishy spot, you stick the needle into the squishy spot and you fish around a little bit with a vacutainer that collects blood, and you can kind of see, it's a little tricky to see, but the blood is filling up. And they are pretty much unresponsive to stimuli, sea turtles are, when they're laying their eggs. It's an evolutionary mechanism that they have where reproduction is essentially more important than survival. So what happens is during the nesting process, during the actual egg laying process, these animals really don't respond to us. So that's when we have to do the majority of our work. What happens is her fight or flight hormone, so it's cortisol in humans. It's a little bit different in reptiles, but it's a similar hormone that is suppressed during nesting. And so they allow us to manipulate them a little bit during the nesting process without typically any response. Now, this is a loggerhead. She's got a big old basketball head. So we take blood. This is just the other end of it. So this is from a loggerhead. So we're taking blood for general health assessments, assessment of maybe mercury exposure, lead exposure, things like that. So what we're looking for is, you see those two muscles that are kind of the V shape down, the biventor cervical muscles. You stick the needle right into that soft spot and next to those, and again, fish around. This is all blind. You know, it's much easier for a nurse to find blood on us. Our vein is right there, right? These guys, they don't tell us where it is. We can't see it. We can't feel it. It's something that you just kind of get good at. And then you take the blood sample. And the blood that we use for these guys is, we do all different things. So you guys all go to the doctor and get your blood panel for, they tell you your cholesterol is too high, or your glucose is too high, or your protein's too low. We do the same thing with the turtles. It's the same biochemical panel that your dog or your cat would get, or you would get at the vet. And a lot of the blood analytes tell us the same things in turtles as they do in humans or domestic animals. Another thing that we do, sorry for the green scale actually. Okay. So we actually pick these turtles up on the nesting beach. We're the only people in the world that are doing this at the moment. And we have perfected this system. So this tripod that we have is only one of two in the world. It's proprietary to a university out in California that they designed to weigh elephant seals. We thought, they're about the same size. We could probably use it for a leatherback. So the goal of this, by picking these animals up and seeing how much they weigh, we also score their body condition. So we are very judgmental. We say, oh, she's really skinny or she's really fat. But we like the big girls here with the leatherbacks. We want them to be a really large body condition. So that's a scale of 1 to 5, 1 being emaciated, 5 being obese. And we don't really see a lot of 5s on the nesting beach. Again, they're fasting. They're not really eating a lot of food, so they lose a lot of weight during nesting season. But one of the reasons we pick these up is to see if there's anything in the blood that can tell us about her physical health. So we're judging her. We're giving her a score. We're taking her blood. We're looking at her barnacle load. You see this turtle, all those white spots on her, she's full of barnacles. We're looking at shoulder fat, hip fat, the length of how high her ridges are, all of these things that can just give us a general indication of the health. So can we tell, just by taking a small blood sample, how healthy this animal is? So I'm not going to tell you any of those results right now. I'm just going to show you how we picked them up. This is Copley. She was originally tagged in 2013. We saw her about 6 times last year. She was pretty loyal to Juno, and she's huge. So this is how you pick up a leatherback. So when they're laying their eggs, we're digging underneath her. So she's a really wide animal. So she's about 5 feet wide, her shell at the widest part up by her shoulders. And so we have one person on one side digging underneath her, 2 holes, and the other person on the other side, and then you kind of twiddle fingers, and then you put these straps underneath her. And then you lift her up and you say, oh, she's maybe not, she's a little top heavy, so she may be head down. And we're digging out her flippers here because those flippers are so long, right? There's about an 8-foot wingspan. So we're trying to dig those out so nothing on her body is touching the ground. So this is after she's laid her eggs, and you see this animal could care less. I think they like it. It's almost like, sea turtle's not used to gravity, right? They're used to being in the water. So coming on land is incredibly costly, but I think it feels like they're back in the ocean probably. It's probably just familiar to them to be suspended. So this is, take a picture real quick, everybody. So this turtle was 1,200 pounds. So this was the second largest animal that we've ever weighed. The largest, I'll show you a little bit later, is Patricia. She was 1,320 pounds, which for a nesting animal is incredible. So this is a body condition of 4, as you probably could guess, is about as high as we get on the nesting beach. And you put them back down. And what's really funny is when they're in the air, we do this when they're rear flipper covering. So when she's done laying her eggs, she's kind of tamping the sand down, she's patting it down, and she's doing that in the air. She's reaching for the sand, trying to feel it. So there's really no alteration to their behavior. So that's Copley. And yeah, it was a very loyal animal, and one of the first animals we saw this year. So I told you why we weighed them, and this is all big scary numbers that, again, it doesn't matter. But the point is that what we do is we take all of these measurements from these animals. So here we're taking that circumference of Sarah that you see here and me. This is Dot again, which she was very photogenic this year. We dug under her and we're measuring that body circumference. So just that circumference at the widest part of her shoulders tells us her mass, or how much she weighs, at about 93% accuracy. But when you add in how long her shell is, or the carapace we call it, how wide how wide the shell is, and how fat her neck is, we can actually predict their mass by about 97%. So if we plug in all of Copley's numbers here, which is what I've done, her estimated mass was 1,186 pounds. Her actual mass was 1,190 pounds. So an equation that gives us a 0.4% difference. Weighing them was fun for a little bit, and then it got really challenging. It's just a lot to carry on the beach and drive around. So we're happy we have a mathematical equation now that we can do, and we don't have to lift them anymore, and we can now share this worldwide. So everybody can now tell how much a leatherback weighs just by taking a few measurements. And our goal is always animal welfare, improving animal welfare. You see that animal in the air probably didn't care that much, but anything that we can do to do less things to the animal, poke her one last time, lift her one last time is important to us. So you might think that weighing a leatherback is easier, a 1,200 pound leatherback is easier than weighing a 250 pound loggerhead. This is Bailey. Nope. Not one bit. We stopped weighing the loggerheads. We did not even try with the green turtles. So it was just like, just take the weight. It's fine. She never stopped moving. No, we don't do that anymore. And it turns out that the loggerhead, it's not nearly as complicated as an equation. Just how long is she? And that correlates really nicely with her weight. Now the difference with the loggerhead and the leatherback is a soft-shelled turtle. They don't really have that bony carapace, that hard turtle shell like many people think of turtles. They're actually considered a soft-shell turtle. When you press on their shell, you actually can leave a thumbprint in it. So their body mass, their body actually changes as they lose weight, whereas the other species, the shell really doesn't. And that's why we can get those accurate measurements more reliably from the leatherback than the other species. So a lot of the work that we do, aside from the health, which I will touch on a little bit, is satellite tracking. Leatherbacks are global travelers here in the United States. Each one of these different colors represents a different leatherback that we've tracked, and they're really fun to track because they cross global boundaries. So our turtles in the state of Florida, a lot of them go up to the Carolinas. There's a lot of jellies up there, especially when it gets cold. They really like it in that area. It's called the Mid-Atlantic Bight. It's just where the coastline kind of makes some curves around the ocean. But a lot of them go up and cross these international boundaries into Canada. And we're seeing a lot of turtles that forage up in Canada aren't just coming down to Florida. They're going down to French Guiana, Suriname, into South America, a number of different places. They're going into Central America. Turtles in the Pacific Ocean forage off the coast of California, like that one I showed you earlier. And they actually nest on Western Pacific and Papua New Guinea. So they're making transatlantic migration. So this is why these international laws are really important for a lot of wildlife species, is they don't have state boundaries. They don't abide by the same rules that we do. And it's really important to realize that. This turtle right here would be a body condition of 2. So you saw Copley before, really beefy, but you can see these big high ridges on this animal. Her shoulders are a little sunken in. So that would be an animal that we would have given a body condition of 2. It doesn't mean that she's unhealthy. It just means she's getting a little thin. It's probably time for her to go back to her foraging area. And this is Patricia, that 1,300 pounder. So you see the difference here. It's quite obvious. Huge shoulders. When this turtle came up on the beach, you could just tell from a distance. And we had 2 turtles up at the same time. I was like, just leave the other one. Come and see this one. So we weighed her, we satellite tagged her, and Patricia went up to Canada as well. And what's really neat is sometimes people in the water see our turtles. So this is a female named Chip Block, after one of our board members' husbands. And it's a female, it's 2026, we don't go by the gender norms in turtles. But this turtle a picture was snapped at a fishing pier in North Carolina, and was sent around all these listservs and emails trying to figure out who it was. And we could tell based on her location, and we paint our tags blue. And the reason that we're doing a lot of these tagging, there's a number of different things. And one is to tell us where in the water do these animals primarily hang out? Where do they like it the most? And where might that overlap with a lot of these risks that these animals experience? And what you're seeing here is it's just a density map, essentially, where all these tracks in the state of Florida have converged upon. And this red area is their home range, or their core area where they really like to hang out the most. The yellow, they like to hang out there too, not as much, and the green a little bit less. So we can use this information to make inferences or recommendations to managers and other conservationists to improve protections in local waterways. Another thing that we're doing with them is re-tagging the same animal more than once. We've done this a lot with loggerheads and other species, but it really hasn't been done a lot with the leatherback. This one was a really neat one. So this was a leatherback that was tagged as a juvenile, so she wasn't reproductively mature yet. She was caught in North Carolina and foraged and swam around this area, looking for jellyfish. 5 years later, she came on the nesting beach. Her tag was no longer transmitting. It stopped up in the Carolinas. But she matured in that time frame, in those 5 years, came back. She still had part of her tag attached to her, so we removed that, contacted the original tagger, and put another tag on her. And if you just look at these, it's nearly identical. And changing essentially her physiologic state from a juvenile that's non-reproductive to a reproductive female that came down to Florida and then really just likes those same areas. So this is the next step. There's a lot of things in the blood that can tell us about where animals have been, but they won't predict where the animal will go. But that's what we're trying to answer with this is, can these, what we call them stable isotopes in the blood, tell us can we predict where the animal is going to go? And so that's why we're doing these double tagging of the same animal. Here's another one. This is Peach. She's top 3 favorite for me. Of all the turtles, she was back in 2025. We satellite tagged her in 2023. She transmitted for quite a while, from April to January, so about 8 months or so, 9 months. She liked the bite, so she didn't go very far. She's a big animal. Body condition for her. This is a scar here from a fishing line that was wrapped around her shoulder. So where Peach came, she likes to come late in nesting season, but she came up and we got really excited, and then she false crawled, meaning she came up on the beach and then left, and we were like, ugh, and threw us for a loop, went north, nested, and we barely caught her in time, but we were able to put another satellite transmitter on her 2 years later. And if you overlay these, it's pretty identical, right? So people say turtles are stupid, and I couldn't do this without a GPS. None of us probably could. And I just think people use human intelligence quotients to try to put those onto animals, and it's just very different. The leatherback turtle is very good at being a leatherback turtle, and their smarts are very different from what you might consider to be a human smartness level or intelligence level. But Peach is pretty cool. Another one that we had is Bodie's. Bodie's was famous. She made Southern Living magazine, so we weighed her, and she was about 1,000 pounds, so another really big girl. She's named after the Bodie's constellation. We all called her Boots for a while until somebody was like, it's Bodie's, it's the constellation. We're like, oh. We like Boots better. But so Bodie's is another OG, right? One of those original turtles, tagged back in 2002. She's got a 25-year nesting history with us. She's very big. She's pretty loyal to Juno and Jupiter. Seen her about 20 times. We satellite tagged her early on in 2024. She was actually one of the first turtles that was satellite tagged on Juno Beach back in 2002. And so we wanted to see if she's 25 years later still going to the same spot. Spoiler, she did. But she laid 11 nests in 2024. And this is a great representation of that. So you can see these 6 nests that are located in this box. That's Juno and Jupiter. That's the area that we monitor at night at Loggerhead. And we knew this because we either encountered her or her satellite transmitter told us that she was on land. However, sea turtles are hedging their bets. So they don't always lay, people say, oh, they come back to the exact same beach where they were born. Kind of. It's not quite so cut and dry. It's more like the same region. So Bodie's likely hatched in Florida, and she nested all the way up in Fort Pierce. She laid another nest like in Stewart area, a couple up in Blowing Rocks and a little bit north, and then one down in Boca. This is a 80 linear mile stretch of beach that this animal laid at least 11 nests across. So if you think about it, if a hurricane came and hit Juno Beach right on, these 6 nests would be wiped out, but maybe she's hedging her bets. Perhaps this area or a little bit further north or south didn't quite get hit as bad with the storm. And so that's why sea turtles lay as many nests as they do and as many eggs as they do, because the survival rate is so low. But if they spread them out in space and time, there's a higher chance that she might have some animals that survive. This one's our pride and joy, is Shirlene. Shirlene was tagged, I think, in 2013, 2015 time frame. We tagged her in 2023, and her transmitter lasted for about 700 days, which is our record. I'll show you, this is just the video, 907 days of Shirlene, so it's just really remarkable. I'm gonna narrate instead of making you listen to the elevator music. So we tagged her on the beach, and you see the miles that she's traveled is on the bottom, and the time and the date. So leatherbacks make those big loops in between each of those nests, and then she went up to Nova Scotia, went into the Gulf of St. Lawrence. There's lots of good jellyfish there. Then she went over to Newfoundland area, and this is kind of odd behavior for a leatherback. We were kind of perplexed by this, but that's typical foraging, kind of those tiny little movements that you see. And then she went into the middle of the Atlantic Ocean. We don't know why, following her friends, who knows. We thought, oh, she's gonna be an annual reminder. She's gonna come back in the same year. Nope, she went near Bermuda, went back up to Canada. So right now she swam 26,000 miles, right? So it's still going. back up to Newfoundland Gulf area, foraging on jellyfish again. Lost transmission there. That's what that straight line was. And then she's like, oh, it's time to breed. So then she swam down, and we were again so excited to get to get the entire migratory cycle is unheard of. So then she stopped transmitting off Puerto Rico, and we're like, no. And then she turned back on when she came over to Florida, and the text kept missing her, and we couldn't get there in time. So we finally got another tag on her, and then she went back up to Canada, 907 days, 60,000 miles this turtle swam. And then she stopped transmitting, so you can see her track from 2023, 2024, and 2025. Just a really crazy story. And Shirlene is our deepest diver as well. She dove to about 3,600 feet when she was out in the middle of the Atlantic there, likely foraging for food, possibly evading predators. But yeah, Shirlene's a special one. We didn't know she was at first, and then did some cool stuff. We also tagged the other species. This is led by our director of research, Sarah Hirsch. She did this for her master's while she was working full-time, and this project has exploded into a number of different things. The more science that you do, the more questions that you get. But you can kind of see the loggerheads don't go nearly as far, but their journeys are just remarkable as to how precise they are. Most of our turtles go up north to the Bight. A lot of them, the loggerheads, are foraging on hard-shelled crustaceans and mollusks. So up in the Chesapeake Bay, you've got blue crabs, right? Humans like blue crabs, turtles like blue crabs. So there are a lot up there. Some of ours are smarter and go vacation in the Bahamas for a few years. And then we have a few that go over into the eastern Gulf of Mexico. And what we're finding, the goal of this tracking project is a little bit different, is to see how many nests the loggerheads lay every season. It's something that we don't know for loggerheads on the east coast of Florida. So using tissues in the animals, we have predicted that there are 4 primary foraging areas for the loggerhead. The red is the eastern Gulf of Mexico. The yellow is we'll just call it the Caribbean for ease of language. You've got the South Atlantic Bight and the North Atlantic Bight, or the Mid-Atlantic Bight. So those are the 4 typical areas that we would expect these animals to go based on those signatures and the tissues that I told you a little bit earlier. We, in all of our 50 turtles that we have tagged, have never found an animal to forage in the South Atlantic Bight, despite many papers saying that they do. So it's kind of an interesting study. But what you see, these colors here match the color on the graph. So turtles that forage in the Mid-Atlantic Bight actually lay fewer nests, 5 on average, compared to turtles that forage in the eastern Gulf of Mexico and the Caribbean. And this could be due to a number of reasons. Food source may be better in these areas. Maybe they're having to swim less distance, which is a lot of energy. They're swimming hundreds to thousands of miles every year. Then they have to deal with the males when they get down here. So it's just really neat that we've seen differences depending on where the animal forages, how fecund or how many eggs or how many nests she lays. So I went through that. So this is kind of the distribution just of the percentage of turtles of where we see that they go. So about half of ours go up to the Bight, like I said before, up here. Another about 2/5 go down to the Caribbean. Not many go over to the Eastern Gulf. But in 2023, we had a record loggerhead nesting season. And this distribution of animals that we tagged, where they went to their foraging grounds, was very different that year. So we actually saw more coming from the Eastern Gulf and the Caribbean than they came from the Mid-Atlantic Bight. So maybe we had so many nests in Florida, or more nests in 2023, because we have turtles coming from different areas, and that could drive a lot of these trends. Maybe some turtles in certain areas, maybe they lay more nests but take more time off, and so that's why, again, we see a lot of these ups and downs every year. Now, the main reason that we do this is, again, the predicted number of nests that loggerheads laid on the east coast of Florida was around 4 to 5, which is what that arrow is showing you here. So clutch frequency is how many nests they're laying in 1 year, or one nesting season, and frequency just what percentage of turtles do we see. So this is the prediction here of what we thought in the past. This is actually what we found. So we're finding that turtles, loggerheads, are laying about 6 nests on average. So in 2023, the state of Florida had 135,000 loggerhead nests. If we thought they laid 5 nests, we had 27,000 breeding females. So now we know that they're laying more nests, which means that our population size is actually lower than we thought. So this is a really strong conservation implications for population size estimates, and Florida Fish and Wildlife is really excited about these data. We're working on writing this up now. This was an incredibly long project, started in 2020, and then we tagged 50 animals along that, across that period, and was incredibly productive project. And one of the things that I'm interested in is, can all of this stuff in the blood tell us what nest is she on? So can all of a combination of these blood analytes and this big huge blood panel that we collect, can it predict what nest she's on? Because if you're doing health assessments or toxicology across nesting season, you don't know what nest that turtle is on. And because she's fasting, her blood values actually change across the season. So her protein declines, her hematocrit, or how much red blood cells she has, that declines across nesting season. A lot of these values are changing, so I want to see if maybe we don't need a satellite tag to tell us how many nests they're laying. Can the blood do that? And it turns out kind of. About 50% accuracy is what this graph shows. So observed is on the bottom and predicted is on the y-axis there. But what we found is that indicators of protein and lipid metabolism, again, they're not eating. So as they're fasting, a lot of these values are changing. Triglycerides are declining. Uric acid is declining, which is a byproduct of protein metabolism. Lipase, which helps break down fats in your body. So these things that you would kind of think about would predict nest number are actually, not super accurate, but within, you got a 50-50 chance. It may be a little bit better to see it maybe just early versus late nesting season. We are finding with some of the green turtles that we're tagging, this might be a little bit more accurate. And just to give you some of the, again, just to highlight some of our favorite animals, Libby was tagged in 2021. We re-encountered her in 2022. That it happens, about 5 to 10% of our animals come back every year. It's not common in the sea turtle, but some of them do. But Libby doesn't lay very many nests. She only lays about 4, and then she leaves. So maybe that's why she can lay nests every year. So after that second year, her tag had been shed, and we put another satellite tag on her. Again, nearly identical from year to year. So we really can tell a lot. We don't need to keep tagging the same animal, most likely. And we can say, okay, Libby forages in the bite, and we know that. And now we can look at the blood from a lot of these animals, and are they healthier up in the bite? Are they exposed to more lead down in the Caribbean? Or a lot of those kind of questions we can now answer. Dolly's another one. She's a hybrid. Sea turtles can hybridize. If you didn't know that, everybody hears the rule that animals, when they hybridize, they can't reproduce, right? You think of a mule. However, the lower you get in the animal totem pole, the less true that is. So Dolly is a hybrid between a loggerhead and a hawksbill sea turtle. It's actually quite common for sea turtles to hybridize. In Brazil, their nesting population is comprise about 50% of hybrid hawksbill loggerheads. And Dolly does great. She likes to false crawl a lot, so she is very picky, but some of her nests had 100% hatching success. So very successful animal, named after Dolly Parton. Who doesn't love her, right? So the hawksbill, what was funny is I wasn't out this night, but Sarah called me, and she had already prepped the shell. So what we do is we clean this area really well. That's where the tag goes. You got to get rid of all the barnacles, all the algae, all the stuff that's growing on the shell. And she called, she said, I have a turtle that looks like a hawksbill. Should I tag it? I was like, yeah, go ahead. So you can see by her face is hawksbill. They've got that hawk-like beak. They eat sponges and corals, so their beak is a little bit longer. But they're actually a little bit bigger, but they still have what we call imbrication. So their hawksbill shell overlaps, each scoot or panel on the shell overlaps one another. So the hawksbill is really easy to identify. So they still have that, they're just big. So we called FWC the next day, and we're like, hey, we tagged a hawksbill. And they're like, that's not good. You tagged a critically endangered species without a permit. So that was fun. Luckily, her genetics came back 50% loggerhead, which by the state of Florida means that she's a loggerhead sea turtle. So we were in the clear. She laid 6 nests and came back 2 years ago, just south of Loggerhead, and we tagged her again, did the same thing, and went right back. She's a Caribbean turtle, which makes sense. The hawksbill's like the Caribbean. Another one, this was just a diver down in Boca that sent us this. We knew it was our tag. It's a blue tag. This is lemon drop. Weird turtle, only laid 4 nests also. Hung out in Boca for a while and then left up for the bite, but she was there for like a month, which is kind of weird, but she looks like she's in great habitat. I wouldn't want to leave either. And you can kind of see they walk along the bottom. Most people think that they're suspended in the ocean, in the water column, which they are. But if you feel the bottom of a loggerhead's hind limb, it's actually very callous, and it's because they walk along the bottom like that. So we got quite a few people have been seeing our turtles in the ocean. So another thing that we do with this is the same thing with the leatherback. This yellow represents the nesting beach. The white is just where we tagged animals, and the blue areas are the core areas, the really strong areas where these animals hang out. The loggerheads hang out the most of the time. See, really close to shore, and unfortunately it's right by the Jupiter Inlet. They love the Jupiter Inlet for some reason, where there's a lot of boat traffic. But what we can do with this information is we know that a lot of our animals that are on our nesting beach have been hit by boats. So about 10% of all of our turtles that we see on the nesting beach have a boat injury. This is from a leatherback. This is the head over here. This is her carapace. This is the loggerhead. These are healed, but you can see they survived. And what we can do is then make again more recommendations to the sea turtle protection zone that we have at Loggerhead. It's an initiative that's in the entire Palm Beach County. Go slow for those below. And what we've done with our tagging is we now know where these animals are hanging out. So more targeted efforts in these areas where these loggerheads are, and then we can better inform conservation decisions. So I'm not going to really talk about the greens too much. We have started satellite tagging the greens. We did 4 this year. They laid 6. 3 of them laid 6 nests, and one of them, Lucy from St. Lucie, laid 7. She's an old girl. She was originally tagged as an adult in 2003, so that's like a 50-year-old animal. She laid all of her eggs right in front of Loggerhead. She didn't spread them out. This is an example of an animal that has really strong site fidelity or loyalty to a certain area. But she laid 7 nests, and we're actually finding some of these blood predictors in the green turtle might be a little bit better than the loggerhead at trying to figure out what nest number they're on. And this is why I don't like the greens. Is they take forever. They're like 3 to 5 hours, 2 to 3 hours to nest. They just are so picky. They crawl really far and then they turn around and do nothing. And you can see this is Madison. I'll talk about this in a minute. This is Madison. She's in vet school getting blasted in the face by sand by a green turtle. And we say, why do we do this? But sometimes the green turtles, they are very entertaining. This was a nesting female that we tagged years ago that we named Jeff. And this is a male attached to her coming onto the beach. She is like, please get off me. So they do that. They will come on land to get the male off of them. She is not ready to mate. Actually, by full chance, I saw her nesting 2 weeks later. So I saw her mating and then nesting. Crazy. So why do we do all of this? Again, I don't need you to look at all of this. It's a lot of graphs. But all I need you to pay attention to is this is the leatherback population in the northwestern Atlantic Ocean. And if you see every population except for Guadeloupe across this 10-year period from 2008 to 2017 was declining. So those yellow down areas. So again, I mentioned earlier, the leatherback has been uplisted from, downlisted from least concern to back to endangered, and this is why. So this is why we do what we do. We're trying to better understand these threats, better understand impacts to climate change. So if you look at Florida across this time, we did see an overall decline, but if you go back even more historically, Florida's leatherback population is doing okay. And that's all this blue means up here. Is Florida is really the only place in the whole Western Atlantic that has a positive growth rate of their nesting population. So we need to know why that is. We need to understand Florida nesting leatherback behavior. and these trends over time to make these decisions. And this is just a simple graph. We've got ambient air temperature and our emergent success, so how well our nests are hatching over time in the face of climate change. So as Earth's climate warms, these are lines based on real data that we see on our beaches. Seeing leatherback emergent success is declining over time, and so are the loggerheads. And so, these are some of the big questions that we need to better understand and why we need to protect these guys. And then additionally, you might know that sea turtles have temperature-dependent sex determination. So the temperature at which they incubate determines the sex of the offspring. So hot chicks, cool dudes, and sea turtles, it is opposite, and not all reptiles follow that rule. Alligators are on a spectrum. But what you can see is we monitor the temperature of a lot of these nests. What you can see is the prevalence of the majority of our nests, they're producing mostly females. We do have some males being produced, that's good. But there are some beaches that are reporting 0 males being produced at all. And so over time, this could become problematic. And this is one of our primary areas of focus. We also see bonfires on the beach. Some kids did this year. This could be right on top of a turtle nest. Don't build bonfires on the beach. They gassed this up. It was crazy. It almost caught the dune on fire. So all of these threats that these animals have that we've often caused are leading to some of these population declines. But there is a silver lining, obviously, we've seen with the green turtle. And we want all this so these animals can return back to the ocean. And just want to introduce, as I finish up here, I don't do this alone. I'm probably the least important person up here. I would say these ladies keep us functioning. And before we hired Katie, we actually had a department full of blue-eyed individuals. I think she's Hazel, so she's kicked out. So Katie Fowler, she was our postdoc scientist. She is leading a lot of this temperature work, a lot of this hormone work that we're doing to better understand sex ratios. Sarah has done all of our satellite tracking work with the Loggerhead. She's raised over $250,000 over the last 5 or 6 years to do this work. Shelby's in her second master's degree learning data analysis, has just really incredible. You know who this moron is. And then Jen Riley is our field operations manager. She's the deaf individual that's really increased programming for the deaf and hard of hearing community that otherwise wouldn't have access to a lot of this stuff. So we have a really special team. Most of us have worked together almost 10 years, so we're very close. There's a lot of trust. These pictures of us are very good. This is normally what we look like during nesting season. So this is maybe how people see us when we're in the office, but usually we're not that good looking. And this is some of the other fun stuff that we do. This isn't really related to anything I've told you, but sometimes we do go out in the water and catch these animals. So this is Rebecca, this is a good friend of mine. This is a loggerhead you see swimming. So sometimes this is called a rodeo, and this is a big turtle, so like, Justin, go. So then we're struggling with her under the water, we can't breathe, this animal is huge, wrestling her, and then you have to yank her up, don't get bit. And there are some expletives at this moment. The current was taking us, so that's how we catch sea turtles in the water a lot of times. And then I'm going to end with this. If you've never seen a sea turtle on the nesting beach, I've told you guys I've had like 40 favorite things about them, but this is, aside from the grunting, this is probably also one of my favorite. So sea turtles glow. So this was captured by a National Geographic photographer, and sea turtles, the back, especially of the loggerhead, is a living ecosystem. It's got barnacles, it's got shrimp, crabs, algae, and these little bioluminescent algae that are on it of different species. You see these different colors that are coming up. And this photographer, Babak Trefreshi, is very interested in just light. And he was actually, because he had a very expensive camera, was actually able to capture this, which we've never seen before. So with that, I know I talked a long time. Thank you guys for listening. Thank you for coming. And with that, I'm happy to take any questions that you might have. Yeah.
So of course you talk a lot about females because they're the ones that come up in that.
Mm-hmm.
But where do the males hang out, and do you track them also?
That's a major question. So the question is about male sea turtles and where do the males go? Or it's kind of an unknown because the females come to us and the males, what we know a lot about them is from rehabilitation studies. So males that are tagged and after they've been released from rehabilitation. The males are likely going to the same places as the females with foraging. It is more likely that the males are probably following the females down to mate early in nesting season, mating, and then returning. Another fun fact about sea turtle females, they actually store sperm. So they can mate early on in the nesting season with multiple males. We've found clutches with up to 8 fathers in a single clutch. Not fun for the female. But it's likely that the males come down and follow them and probably don't stay as long and then just return a little bit earlier. But the foraging areas are the foraging areas. They know evolutionarily that's where it's from. So a lot less is known about the males, but anytime we get an adult male in our hospital, we place a transmitter on that individual. Yeah, in the back.
So you mentioned that you guys go as far up as Cougar Inlet.
Mm-hmm. And so the question is, who does the monitoring? So night monitoring is pretty rare. That's only done by maybe half a dozen groups along the entire state of Florida. It's the Fish and Wildlife's take on that is let the animals nest naturally or as naturally as they can. But the morning program, that is done across almost every beach in the state of Florida is monitored by somebody. And it just depends on, it's different groups. So a lot of it is run by just strictly volunteers. There's Ecological Associates is probably the one that does it up here. You've got Blowing Rocks, different agencies take different stretches of beach. So that's how it kind of works. It's just a huge network of about 1,500 permit holders across the state that makes all of this happen. All of those data are required to be reported to Florida Fish and Wildlife, and then they're the keepers of those data. Yeah. Yeah. In the lagoon? Do they nest? Do they nest are they present in the St. Lucie River? Or I'm not understanding your question. Are they reproducing in the same? So they're very prevalent. Yes, the loggerhead is very prevalent in. They can be found in the intercoastal areas, and it's rare for them to go into any kind of. They would rarely go into fresh water if ever. But yeah, they will not nest in the intercoastal waterway typically unless they're really desperate. But yeah, they're found primarily what you'll see in the lagoon systems are juvenile greens, but we do get leatherbacks and loggerheads in there sometime as well. Yeah, right there.
Is there any rivalry between the various turtles and the nesting places? Do you ever get into little...
Yeah, so the question is, do the turtles beat each other up? Maybe not, not on purpose, but what's interesting is they nest differently across the season. So the leatherback comes in February, March, and nests into like June, July. The loggerhead doesn't show up until April and nests into about August. And then the green turtle comes in May and nests into September. And they spread their eggs out in time, and they also do it in space. So the loggerhead and the leatherback are more mid-beach species, and the green turtles tend to crawl to the dune. So while we do see a lot of interactions, they're never I've never seen one bite each other. I've seen them crawl over one another. So there's no real aggression, but there is competition for space. But over time, because of how long they've been doing this, they have kind of worked it out themselves. Yeah, I'll do another one over here. Yeah.
When they do swimming up north, do they go as groups or is it a single turtle go out?
Sea turtles. So the question is, are they solitary or social? Sea turtles are solitary animals. There is some evidence of herding behavior in the juvenile green turtles, but for the most part, like if you go to a rehabilitation facility, typically They're in their separate tanks because they will bite each other. They do not play nice in the sandbox with one another. So on a foraging area, yeah, you might see a lot of turtles there, but the really only time that they're interacting is during mating or during like the aribatas with the Ridleys, where you get all of them coming on shore together at a time. We'll go in the middle here, yeah. That's one of the million-dollar questions is what do we do? We know the nests are too hot and we see this emergent success declining over time. The problem is when you have 160,000 nests in the state, how do you protect all of those? So in the state of Florida, the mantra is kind of let nature be, at least for the time being. In other parts of the world where maybe their populations have crashed a lot more, there are hatcheries and nest shading. So they'll actually put canopies over the nest to shade them. They'll water the nest to cool them down. And that actually might produce more males and increase survival as well. So a lot of areas, some areas where there's like poaching and heavy, like a lot of just nest loss, they have hatcheries in protected areas. But here in Florida, the only time we relocate or do anything to intervene is if there's a sand placement project where we know sand will be put on top of the nest. We'll move that nest.
Justin, we don't have a ton of time left, but I'd like to at least grab one or two questions from our Zoom audience. This is a question about the Loggerhead Hawksbill hybrid. Have you noticed any differences in clutch sizes? Are they typical of a Loggerhead nest, or is it a higher egg count like Hawksbills? And have you looked at the paternity of the offspring from Dolly?
Yep. Yeah, good question. So her eggs are smaller, and she does have larger clutches. So the Loggerhead on average lays about 100 eggs per nest. The Hawksbill will lay 120 to 140, and they're smaller. And we did see that with Dolly's nest. So Dolly was reproductively more like a Hawksbill. We do send all of those samples out for genetics, and I believe Dolly mated, her offspring were 75% Loggerhead, 25% Hawksbill, meaning she mated with a Loggerhead male, at least that year that we tested it. Yeah. There's not a lot of adult Hawksbills in the water here, especially during mating season, so it's more likely that she would mate with a Loggerhead. Yeah, in the back. That's another million-dollar question in the sea turtle. So thank you. The question is, how do you determine their age? There really is no way. There was some studies a few years ago where if you cut the femur in half of a dead animal, you could count the growth rings. Obviously, live animals don't like it when you cut their legs off, so it's only beneficial in dead animals. And once the animal got into its teens, it became less accurate. So really, aside from tagging and estimates, or there's some things, it's called mutilation tagging. It's as horrible as it sounds, where you might punch a piece of the shell out in a certain pattern of a hatchling and then wait for that animal to return to nest. Then you at least know how long it took for that animal to come back. But you're thinking most hatchlings are getting eaten or not surviving, and so those studies are not very fruitful. So there really is no way. We say that they likely live human lifespan. There's turtles in captivity that are in their 80s and 90s. But yeah, there's no real way to tell. Yeah, someone back here, yeah.
What caused the increase of the turtles from 2000 all the way up to was it commercial fishing control?
Yes. So the question was, what caused the increase in the turtle populations that we're seeing? It was actually a change in the fisheries. About 30 or 40 years ago, they required the turtle excluder device, or the TED, many of you may have heard of, in shrimp trawls, where a lot of turtles were getting caught and drowning in. So what the turtle excluder device does is the turtle swims in to a large shrimp trawl, hits a grate, and then there's an opening, and it allows the turtle to swim out while the target species to stay in the end of the net. And it is that change that is directly attributed to the increase in loggerheads in the northwestern Atlantic Ocean is these fisheries alterations, yeah, because so many turtles were drowning. Yep.
So we have time for maybe one or two more questions here from the library audience. I see some waving hands over on Justin.
Oh, I'm sorry, I can't, it's the light.
You talked about the distances these turtles have gone.
Yeah.
How fast do they go and can you predict where they're going to nest?
So the question is, how fast do they swim, and can you predict where they're going to nest? The nesting thing, no, we can't predict it. I mean, it's always, we satellite tag a lot of the animals, the first animals of the season. Some of those turtles we never see again. A lot of them we see every nest. So it's really just hit or miss. And what we think is happening is as the turtle is aging, the mother is getting better at finding where she wants to lay her eggs. And so over time, as a neophyte or a first-time nester, she may lay all of her nests in this space. And then over time, she might get we're finding that they're getting a little more accurate. And how fast do they swim? The leatherback never stops swimming. That animal is completely pelagic, never rests, never stops. If you do Shirlene's math, it's about 6 to 7 miles an hour constantly. The green turtle can swim up to 20 miles an hour at bursts, but that is not common. I mean, usually they're just they're turtles, right? Unless there's a predator, so yeah.
Well, unfortunately, I know we still have a lot of hands up here at the library, but the library is closing in about 5 minutes, so we have to pause there. But you guys can help me give Justin a big thank you.
Thank you.
What an amazing presentation.